Well, hello and welcome to the ASP.NET Community Stand-Up. Hey, Damien.
Hello, everyone.
So my name's John Galloway. I'm a PM on the .NET community team. And lately, there have been a lot of, this has been a long time thing. People have been confused about implementing security in ASP.NET for a long time. But recently, I've seen a lot more discussion about this. And you're one of the experts. I always read your blog to keep up on things. And we feature your blog on the community stand-up all the time in our community links. So I reached out to my friend Damien Bowden, and welcome.
So, thanks for having me. So, it's delighted to be on the show, and it's one of my favorite topics. Authentication is lovely, and security, and it's really interesting and great. Always new stuff to learn.
So how did you get into security with .NET? Is that something you've been doing for a while?
Well, yes, I've been doing it for now maybe 5 to 6 years. Like I started off learning just doing .NET, and then when I was working with .NET projects and everything, I realized that I didn't understand security, and every time I had to do a security solution or something in the for a client or apps or whatever, I started figuring out, oh, okay, so I don't understand this, so I'd like to start understanding it. So then I start watching back in the old days, figuring out how to do the authentication with the .NET was that time, and then I was watching things from I think Brock Allen's videos. I learned it off like he was doing a whole series on the identity stuff, which was really cool, and then I got really interested, and then I started saying, okay, I want to learn this more, and then the more you learn, the more you realize you don't understand, and then
Yeah.
I just kept building it, and then say, oh, I want to learn this, I want to learn that, and yeah, I think it's really exciting.
Awesome. Okay. Well, I have just a few community links to start with. They're all security focused. So I will switch over to that, and then I will we'll move over to your screen after that. So I've shared the links in the chat. They will be in the show notes, and they're all here. So here we go. The first one, there was a tweet thread that Damien Edwards shared. Just a second. I forgot to hide my notifications. Bad job, John. So Damien posted a short Twitter thread, ASP.NET Core Decoder. So he just shared links to the docs, which this is really useful. This is ASP.NET Core Identity. This is for your standard kind of username, password. I think of this as kind of the simple thing, but then this also works with like Twitter, Facebook, social auth, etc. Then also linked to overview of ASP.NET Core identity or authorization. Authentication. He linked also to Microsoft Identity, and then to Identity Server, and then also this community project, OpenIDICT. And then bonus tweet is this very recently updated Learn module from Cam Soper. And so there are a few of these things that are linked here. This is that recently published Learn module from Cam Soper. This is ASP.NET Core Identity. This is just the basic stuff, right? So this is kind of a, I don't know, I guess it says an hour. I think you can probably get through it even faster than that. Then there's also this getting started with Microsoft Identity, and this is working with like Azure AD. So we actually have an upcoming event on the 30th where we're going to be walking through these two modules. We have Cam Soper and Christos Matskas, who are the experts on this. And so that's, I'm shamelessly promoting that here. That's coming up in a few weeks. And then the only other thing I have to share, this is something that you put together and shared, Damien. This looks like an amazing resource. So this is a list of links and everything. And with that, I'll just turn it over to you.
Okay, thanks, John. Super. So what I was thinking today is I'd just like to maybe give an overview of what I think is really important for someone getting into app security, what type of disciplines and what you can work on. And what I thought when I was first getting into security, I didn't know where to start. So what I've done now is I type of have a different groups, different topics where people can start learning. And then what I usually did at the start is I focus on one topic, tried to learn that a bit, and then I moved on to a next topic and learned that a bit. So I'd just like to give an overview of what's out there for a developer or an architect or someone that develops code and likes doing .NET code or JavaScript and so on.
Okay.
Then After that, I thought I'd just go through then what authentication flows I recommend, what's still usable today. And with these flows, I have them all linked now. This is more or less what I use nearly for all my applications, and I nearly have no other requirements apart from these flows. And some of them can be simplified. You don't need all of them, but I put different flavors of the same flow in as separate flows because I think it's important to know when to use which. Then maybe after then, just to explain how you can secure a single page applications, and then also how you can protect APIs, but all just at top level, just a quick overview because we don't have the time yet. And hopefully the idea after then with the links and then with the code examples I show after as well, people will know where to look for what, because it's not actually that complicated, I think, security, if you don't try and do it yourself or just use best practice and recommendations. But the problem is how to find out what's best practice, where should I use, where should I use. For example, simple things like choosing which IDP is the best IDP for your architecture, for your solution. It's not easy to choose, but it depends an awful lot of so many different factors. And if you can figure out which IDPs you should use, and then you can figure out which clients to implement for the IDPs, then you're already winning. Like so.
So I think you defined it before, but IDP, that's identity provider?
Yeah, correct. Yeah.
Okay.
Sometimes we call it secure token service, or identity provider is a name we use as well. Okay,
let me start with the simple question.
Mhm.
Way back in the day, all we needed was a username and a password, and we stored a password, or maybe we, if we were good, we put a salted hash of the password in a database.
Yeah.
So sometimes I'll talk to people and they're like, why did we make things so complicated? Why do we need all these different flows and different things? Why isn't username password good enough?
Yeah, because so that's a hard question to answer, but it's simple that the more your application does and the more you want to steal, the more creative, more inventive people are to find ways to get into your application and trick you to using it. So there's one thing is about making the application secure so that it's harder for people to get into it, technical protections, and also making it hard for people to make mistakes. For example, copying a password and username will be you save it on your desktop, or you forget it, you put it into your browser, the browser gets cached. So many different things that can go wrong. So the flows is type of a natural development, and all this ways of protecting, just the OpenID Connect and OAuth groups, which are always developing new ways to protect against known issues or problems that keep arising. And then also you have many different type of application types, and each application has a different properties, or you have different things you have to protect against. Some applications don't run in a trusted zone, other applications run in a trusted zone. So you need to protect them in different ways and also trust them in different ways. So because there's so many different type of applications, architectures, infrastructures, way we use it, they all need a different security solution, and we have to try and make the best possible security solution as possible. It all depends on your environment. And then, of course, then traditionally it always came from network security. You had everything behind the front door, which was your firewall. You just was open HTTP. Sometimes you had a lot. You still have that actually in some places. And then in front of it, you put a strong firewall. You paid an awful lot of money for the firewall, and they said that nothing gets through the firewall. But we don't have a secure environment anymore because everything's public now. Even with in the non-public zones, we have different applications running, developed from different people from different companies. So you have to protect every instance, every application to the max, I think now. Trust no one.
Because things are so interconnected, one weak link can like affect all of them, right?
Yeah, that's what I think. So I like to put the security as close as possible in the application, and then you can also add the extra layers. The more security is not just about one protection, this is as many protections as possible. So you do the application security, then you can add the network security, and then you can add the extra protections, and then depending on what type of apps you're producing, you can increase the security by adding more and more from the standards and features. But one of the main things to do is you should not try to invent this yourself. Always look for a solution, some RFC, or I always say look for a solution OpenID Connect, or look for a solution OAuth, and they'll probably have some RFC or solution for your needs. And if you follow their best practice, you're already making a massive step in the right direction. Usually, solutions invented by yourself usually will have problems that you don't think about.
I think that's a tricky thing because especially when you don't know all the different things, you think, oh, I'll just make it myself and I'll make a secure thing and no one else will know how I did it. But anything that you can hack, or is anything that you can put together, can get hacked so quickly. Like that, all these things you're showing here are solutions to 20, 30 years of hacking.
It's also, these were created by really smart people, lots of
Mm,
people working together. They challenged it, they claimed it. How the specifications, the RFCs get created, there's an awful lot of thought process goes into it, and it's really, if there's mistakes in it, it gets reviewed, it gets corrected. It's a long process to get something to be an RFC or a security guide, and that's why
mm.
maybe it's just best to use this, and then um, you can also take part in the RFCs if you think there's something wrong. Together we can keep improving them. And then what's really cool is then when we have implementations which are certified, I always say use a certified lib or a certified IDP, and
Mhm.
then you know that at least you're following the RFC and the best practice. So this is another thing, like if you're using stuff that's not certified, how do you know that it's actually following the best practice? And
Okay.
because technically it's always hard to validate this yourself. So the best thing if it's already validated and then publicly declared.
Okay.
Oh,
All
so
right.
when I'm hoping or trying to get people involved into security, I always say pick one of these disciplines and start with that. So for me, for an application developer, I always say this: one of the first things you should always learn, or one of the basics, is how to implement authentication in your solution. I always say use OpenID Connect or YDCs or OAuth2. The two of them are belong together now because the specifications come in both of them. One without the other doesn't exist anymore, I think, and some of the specifications are being written in both from these groups. So first thing I say is learn how to do the authentication, and if you know which authentication flow you should use for which application type, you're already making a huge step forward. And then of course things like logout, the flows to choose, how to do a proper logout, what type of logout do you need, single sign on. This is all belongs in this topic. So this is one of the things I think you should learn nearly first. Then, of course, when you understand how to do the authentication or get the setup, the next topic, which is the most tricky probably, is how to implement authorization. And ASP.NET Core has a fantastic grunt framework for implementing authorization. I think the policies, the handlers, and requirements implementing that in your application is a fantastic and really flexible way to implement authorization within your applications. Now, when I'm defining the policy, you have maybe a service, you could buy one, or you could use the Azure roles, the Azure groups. Um, that's the ways of defining it. And then when I use that in applications, then I always try to use policies, handlers, and requirements. I never actually use a role directly in my applications because that's for me a tight coupling, and I don't want to have that inside my application because a role in one application might mean something different in a different application. So I don't want to use an external definition or role and tightly couple my definitions to my application. And I think with the authorization policy and handlers is a really great way of doing this. So that's another discipline. I say once you understand authentication, then you can move on and learn authorization, or you could do a parallel as well. There's no thing. What's really exciting at the moment is there's new security standards coming on called self-sovereign identity, and Azure, there's an Azure team that created verifiable credentials inside Azure, and that's a new way of securing your applications, and it's very new. So there's an awful lot of problems still. It's not very, maybe it's not quite usable yet in a lot of use cases, but I think this is a really exciting way, and it introduces a new concept that you control your own data, and that with this then that you decide who gets your data, your P2 data, and not you have to ask a service provider or ask your company. So for example, they own your email, and if you want to log in or they take away your email, you lose your data or you lose your identity. So this makes a new way where you can actually control your data. And then with this, then you have a credential issuer, a verifier, and wallets which you control, which belongs to you. And then it makes a new way of doing authentication, but it has many problems. Specifications aren't finished yet. There's actually a big problem with authentication actually with it because it's a cross-device authentication. So there's no way of actually protecting against phishing with this. There's lots of little problems. Some of the service providers that implement this, they all implement different standards. There's two families of implementations at the moment. One is the SIOP group, and the other is the DCOM v2. And we don't know which one's going to win. Maybe both of them win, but they're nearly like two completely separate identity systems. And then there's some great working groups with OpenID Connect to define specifications, for example, SIOP with OpenID Connect as well. It's not known which is going to win, which standards will step through, how how quickly this would become mainstream. But if you're really interested in learning, and this could become a big thing, and it's looking really interesting. I think the theory and how it works is fantastic. So people are really interested in this. I think you should really look at it. And an awful lot of governments now are considering using this. I'm in Switzerland now, and they're going to push one of these solutions now for the new government EID probably. So there's the EU also have a big movement on this. So this could become really a major thing. And then I think if you want to get started on this, the Azure Verifiable Credentials is a fantastic place to get started. It's really easy to use. They're doing great work on this, and it's very interesting as well. So you could also use this as an extension to your existing authentication solution. So that's type of new world. Then
a few things. You may have you covered a lot there. You mentioned both authentication and authorization, and let me see if I understand this right. So authentication is who you are, and authorization is what you can do. So if I log into a site, I may be an admin on the site, and I can add, delete products, delete users, whatever. Or I may log in and I'm authenticated, but I'm just a user or a customer, and all I can do is buy products and update my own profile.
So that's almost correct. We go a little bit further. It's not who you are, it's who you with the application is. So we say you're an identity. So that's you plus the application, and that's who we authenticate, the application plus the person. Because if you log into your web administration application, you'll have actually a different identity to if you log in with your mobile phone. And then we have a different authorizations levels for those two different separate identities. So there's actually one person, two applications. It's two separate identities, and we authenticate the identity. And this was introduced with the OpenID Connect specifications. Before in OAuth, we didn't have that. So now we have a thing called the ID token, which represents this identity.
So starting at the simplest level, you said, I think OpenID Connect, OAuth 2, those are that's the simplest thing I can get away with.
Yeah, they're the things I always, if you're pushing or doing any standard, I always go for them too. They're I think the two best and easiest things to implement. Now you can add extra layers and different ways to implement it, but if I was implementing or securing any application now, I'd use OpenID Connect and OAuth at the moment.
Okay. Related to that, we had a question come in. This is, what's the best way to authenticate like 20,000 users? Does scale matter for this, or where would you start with for that?
Okay, so it's a hard question to answer because 20,000 users at the same time, you don't ever authenticate all 20,000 at one time. Usually, if it's a user, then you'd probably have a UI application. Each one would authenticate separately. And then scaling, for me, usually I don't implement my IDPs anymore myself. Usually I buy a service, something online, or if I have a complex or high security that I implement myself using, for example, OpenID Dict or using Identity Server. And then I'd have to set up the scaling and that for myself, but that'd be part of your implementation. But usually that's not a topic for the clients. That's a topic for the IDPs or the identity providers. And that's something that usually you could try and buy it. But if you don't buy it, then you have to implement yourself and then you have to scale up and down. So it depends what type of identity provider you choose. But it's definitely not the responsibility of the client. Now, that's the type of maybe change. We haven't explained that yet, but usually I never implement an application where I do my own accounting. Even if I implement my own identity provider because I have a high security or I need to implement some special my standard stuff, which isn't so easy, I need to adapt fast. Then I implement that as a separate application, and then all my UI applications where the business is implementing, where I'm bringing the value for the client, is actually a client using this IDP. I hardly ever put the two of them together. I don't think I've done that ever. Actually, put an identity server together with my client. I usually separate them because I say that's can be reused then, or I could actually use one of the service providers. I don't need to implement this myself, and then I just have to implement the client. So usually nearly every feature requirement I have, I'm actually just implementing an OpenID Connect OAuth2 client, which uses some identity provider, and the scaling and the responsibility for the logins and the monitoring and all the stuff that comes with it is responsibility of the IDP and the systems around that. Does that answer it? Or?
Yeah, it does. Okay, so where do we get started?
Okay, so I'll just finish the list of the other disciplines and then I go through the authentication flow. Is that okay?
Yeah, sounds good.
So another thing I think this is really important for people to know and should learn now is multi-factor authentication, two-factor authentication, and FIDO2 is, for example, for me now, really important. FIDO2 is the only known way for normal web applications which protects against phishing. And phishing, we have loads of companies doing campaigns saying do this, yeah, watch where you click emails. But if you're using FIDO2 with a log in the browser, which redirects to the browser, and you use the FIDO2 standards, you're protected against phishing. So you're going to massively reduce the amount of problems you have. Phishing is probably one of the biggest problems we have nowadays with authentication, I think. And then, of course, you can use authenticators like Microsoft Authenticator or Google Authenticator, which are fairly good, but it's not as good as FIDO2 because they don't protect against phishing. And then SMS, of course, we don't recommend that anymore, but it's still way better than just using a password. So this is another area I say you should understand, that if you're creating or making a new identity provider or you implement it, always choose one that supports FIDO2, I say no. Another area.
Sorry, quick question. I hope you don't mind.
Yes,
somebody asking about, let me see, Duo for MFA. I honestly don't know what that is.
I don't understand it. Is it Duo?
Okay.
I don't know. Maybe you can expand a bit.
Sure, that sounds fine. One other question. You mentioned FIDO2. I don't know if you'll dig into how. So you said FIDO2 is better than two-factor or MFA because it protects against phishing?
Yeah, it's the only two-factor or multi-factor authentication that protects against phishing. So you can use FIDO directly as the only authentication, and then you have the second factor on the keys itself, or you can extend an existing password login and put a FIDO2 multi-factor authentication after that. So you have like something that you know, something that you have, and something that you are. And FIDO2 keys can do all three, actually, depending on what type of key you have. So it's if you can use it as a multi-factor or just direct. But what's really good about it, because the way it's implemented, you have the browser origin is validated, and that's sent over this. It's a private public key, and you save the public keys. So you don't have any passwords. But if you are using a password and use FIDO as a second factor, it takes away the phishing. And that's the problem with authenticators. That's across device, or you get the push notifications. You could be getting a push notification from someone else's, from your website, but you're going through a phishing website, and it's impossible to protect against that. So it's the only one known way. Now you could use PKEs or the certificate authentication, which would also protect against phishing, but then it gets complicated UI. So you have to have the clients have to know has to have a key which knows the server and so on. So for public apps or mobile apps, it's not really a good use case, but maybe it depends what you're doing as well, of course. Okay, so another discipline I think is really important to learn as well, which is very popular, this one you read about, is the Devops Security. So there's an awful lot of security features you can implement with Azure DevOps or with GitHub Actions. And for me, you can keep it simple. You can just many different tools, but simple things is like that. You should always have a completely automatic deployment. And then if something fails, you can deploy again, update the secrets automatically and all this type of stuff. So there's an awful lot of security you can implement by focusing on DevOps security. Then OWASP teams, this is the one we always read about. This is the typical things you read on the internet. All the pen testers usually just check your OWASPs if you have XSS or cross-site script forgery, or all the typical, the top 10s and all this stuff. So this is also really important to know, but this is just, for me, one part of all the security. So for me, what I do in ASP.NET Core, there's a fantastic library from Andrew Locke, what's it called, security headers. And with that, then he does all the heavy lifting for you, and then you can just define in each application that you deploy. If you have an app, there's a certain deployment you can do. If you have a UI, you can a certain deployment you can do, and it can just lock down and disable everything more or less, and add all the headers that's required. And then using this library, then the only complexity you have is really to define the CSP, and then you have other tools to test it and make sure that the CSP works for your deployment. So I always develop also with HTTPS the whole time. I never develop with HTTP, because I like my development environment as close as possible as my production deployment. So local, no matter what type of application I'm doing, even Angular or React, I develop in HTTPS, and then I can turn on all the headers and protect everything. And then I have no images which could be linked with HTTP, or I block CDNs unless I'm doing big applications. Usually I develop enterprise applications, so I don't need massive performance because I don't have many users. I have just complex business flows. And with such applications, then I just turn off all my CDNs, and I use all the local resources, and I can block it. And which this, then I can reduce the amount of attack surface in the OWASP. So it's another area. It's a really big and it's well researched, and there's fantastic material in the internet for that. And the last area I think is one of the most complicated but really important. If you really do need to implement your own accounting system or identity management, ASP.NET and the core identity is fantastic. And then if I was using this, then I would use some type of finished library or finished identity provider. And at the moment, if I was implementing this in .NET Core, at the moment, I use Identity Server or use OpenID Dict. And they're the two solutions together with ASP.NET Core Identity. You have a really good, flexible system, but then you have to implement it. You have to things like key management, rotating your keys, how to deployment, the scaling, how to manage your certificates. Maybe you want to implement certificates, but you have massive advantages with this as well because it's really flexible and you can adapt your system onto future requirements or whatever you want. But you have to then maintain it and implement it, which costs money as well. And if you don't have the knowledge or you don't have that, maybe it's not the best solution. But if you need a flexible solution, it's really good. So there's lots of discussions if you should pay for these things or not on the internet lately. The cost of these IDPs themselves, for me, is more or less nothing. The main cost is actually maintaining the implementation and keeping it alive. For example, ASP.NET Core Identity, when I implemented that first by one client, it was a M4C application, and then it got updated to Razor Pages, and then I had to migrate the whole every UI, every view, which I translated because we had 4 different languages. I live in Switzerland, so we translate more or less every application into English, French, Italian, and English. And then of course, then when I was updating that, which you had to because I had security holes, then I had to also update all the localizations, which meant I had to more or less rewrite the whole UI, and things like that is what costs, and that's the disadvantage of implementing yourself. But then when I'm adapting and implementing, I had a few customization flows for some banks, and then it was really the best tools to have for this because then I could just adapt it and implement the security flows as then was defined. Some of the flows went RFC then or developers, and they went supported by the tools, and then they get supported eventually, but it gives you the flexibility that you need, I think. So that's saying choosing the right IDP is correctly, but it's nearly something you should never have to do. And if you're not strong, you don't know really what you're doing, maybe you should just then rely on one of the identity provider services, which will help you because they support an awful lot of best practices. And then there's lots of known services for this as well.
Okay.
So that's a quick overview of everything I think that someone developing software. If you want to get into security, choose one and go for that. And most of them are production ready, and the self-sovereign identity at the moment is something that could come in the future. Maybe it won't, maybe it will. But it's really exciting to learn that as well. So the RFCs are very good into reading that. They're really interesting.
Okay.
So have we any more questions before I start going through the authentication flows?
Let me see. There's one, and I'm not sure if this is something we'd cover later, but a question on like Azure AD with Blazor WASM that calls a separate API, for example. Where
Okay.
would you start with that?
I could actually show that later. For me, if I'm hosting my own Blazor WASM, I usually host that inside a backend. I'd always deploy that as a single security context. So I deploy that as a server-rendered application, and the WASM part is nothing but it's just a view of my backend application. And then I'd use a OpenID Connect code flow with Pixie, and then I'd use cookies to protect the WASM part of it. So the one application, and then I have no sensitive data in the browser, session storage, or local storage. And with that, then it's much easier to secure. I can add the extra security features, and it's actually, I think it's less complicated. I have a template for that, and then the identity server team, I don't know what to call them, they also have a good solution for that. And I think it works really well to implement it as a backend for front end. Now, if you're just doing a pure WASM on its own with a separate domain API, then you need to find a separate solution, and then you can fall back to whatever you're doing. Now, you have to be careful as well. Azure AD is not the same as Azure B2C. They have small differences, which are quite big actually. And that also changes the way you have to think about securing a single page application or not. So if I'm in Azure, I nearly try to avoid single page application. I usually deploy it now with a backend for front end. But on other identity systems, I don't mind. I think they're good solutions, especially if I can use introspection, or I can remove some of the sensitive data or at least log out.
Can you talk a little more about backend for front end? Is that something you cover later, or is that what's the idea there?
Okay, I'll just jump to that now. So backend for front end is So the problem is before we started off doing server-ended applications, and then single-page applications or the JavaScript technologies like Angular, React, Vue, and Svelte now, they got really popular. And what happens to them, people want to develop them separately because it makes sense because you have fantastic tools for developing the JavaScript applications as standalone, and then you have really good tools for developing the backend. So maybe you have a Java backend, Node.js, or you have a .NET application, which is the one that I usually you do. And then on the front end, then you have a different tools. You have Angular, which have its own tool sets. Maybe you have NX, or maybe you have the React, and they all have their own tool sets as well. So you become really efficient if you develop in your own environment. You use the tools and the code and the way you know it. And then people start separating the applications and deploying them separate. So then it became made sense that you deployed a single page application as a standalone, and it needed a UI authentication, but it couldn't keep a secret because the whole application runs inside your browser. And then the
Mhm.
API then was using an access token, which you got back from your UI. It's a use access token. And then the tooling was separated deployment. So then, of course, the problem is that we're saving the sensitive token data in the session storage or the local storage, depending on what client you're using. Now you can hide it a bit with a service worker, but it's still accessible through the JavaScript. So you still have the sensitive data in the browser, which is accessible through a JavaScript application. And then the idea is that if you remove that, and cookies have been got much stronger now because you have the same site protection by default now. And if you force the same site and secure cookies now, you cannot use them, or you don't allow subdomains either. You can stop the cookie being. It's really hard to share the cookie or rob the cookie. So it's actually nearly easier to secure an application which uses the cookie to share the session in the front end. So with that, then we brought the two applications back together. And with Blazor, it's really simple because it's the same tech stack. So you can put your ASP.NET and core application and Blazor all in one, have one security context and deploy that as one. And it is one because they are tightly coupled. The API and the backend and the UI is a tightly coupled relationship, even if you split it. Even if you just make an Angular or React application, you have a different backend, the API and the UI is very tightly coupled. So
Mhm.
you want to put them together, I think, to keep simplicity, make it as simple as possible. So if you were deploying an Angular application React as a backend for front end, it's no longer a separate application. It's just a view of your backend. And the backend is the one that hosts it, and all the security is implemented then in the backend. And this is my trusted backend that only I control. I deploy it. I have full control over it. I can also keep a secret. I can also implement extra security features. And then the UI view of it then is being shared with a cookie. Now it has disadvantages as well because if I'm using a cookie, it's same domain, and you have to force same domain, and then you also have to add in anti-forgery cookie protection, or you could also use Core's pre-flight to prevent the cross-site request forgery attack. And then also, if you want to use an API from a separate domain, that will not work. So you have to go through your backend again and then do a second HTTP call to the other API in a separate domain. Or you could use the app reverse proxy, which does the same thing, but it automates an awful lot of that process for you. So it has disadvantages and advantages, but yeah, I think security-wise and architecture-wise, the backend for front end is a much cleaner, much better process of security as compared to having two separate applications, which is really one. Because some people have a gateway application, which is made specifically for your single-page application, and there's no need separating them maybe, but maybe sometimes that makes sense. It depends on an awful lot depends on your technology stack and how your development teams work. You haven't A lot of teams have a development team split. I'm a UI engineer, I work on Angular or React, and I'm a backend engineer, I work on .NET Core, I work on Java. And then you have two completely separate teams that don't work together, and then maybe it's easier then just to separate the security as well. But then of course then you have the unsecure or the sensitive data in the browser, which is something that we'd like to avoid if possible.
Okay.
Does that help?
Yes. Yeah, it does.
Cool. Okay, so what I thought now, I go through some of the authentication flows, which I think everyone should know. There's an awful lot of questions. If you if you're implementing a client, no matter what type of client, there's always one preferred authentication flow for this type of client. And if you can choose, say, I'm implement application X, it's a web application, it's a server-end application, not a server-end application. If you know which authentication flow you should choose, you're already making a massive decision in the right direction. Now, Azure AD and Azure B2C does all the same things more or less, but they add a layer on top of it and rename everything. They call their system called the Microsoft Identity Platform, and they implement very similar flows, but not the same to what I'm going through here today. And there, if I'm doing Azure AD or Azure B2C, I always use the Microsoft Identity Web client libraries. But that's just a client library which uses the identity provider from Azure or Azure B2C. For everything else, I use OpenID Connect or OAuth 2. And both of them systems, they all use OpenID Connect or OAuth Flow roughly. So there is a few little differences, but there's, how to say, small deviations away from the standards. So Microsoft do a lot of little things differently, but it's still based on OpenID Connect or based on OAuth 2. So
Okay.
the first flow, I think everyone should know, is the OID or the OpenID Connect authorization code flow. And this flow is something you should always use with a server render application now. So if you're starting off a new project, use the OpenID Connect authorization code flow. And this is without Pixie. You should always use Pixie as well. That's the proof key of code exchange. I'll explain that later as well. But I just thought I'd show you the authorization code flow first, and then after I'm showing you the native apps, how the Pixie helps protect. But I always implement a confidential client if possible because I like to authenticate and authorize the application as well as the user. So if you can use a secret, you should always use a secret. So this is for applications which you can trust. So the flow is really simple actually. It's a two-step authentication flow. So what happens is that when you open up your application, you redirect when you click the sign in button or you want to automatically log in, you redirect to your secure token service or your identity provider. And then if all the claims and the parameters are correct in the URL. At the moment, it's URL, there's new specification, but you can put it in the body if you want. But if everything is correct in the URL, then the secure token service will allow you and the application to authenticate. So the user will get presented with a username password directly in the token service. This could be Azure, it could be Keycloak, it could be any IDP. And then if everything's correct, then you can do your two-factor authentication. You can use a Google Authenticator or you can use FIDO key. And if all is good, then you give your consent then and say, yes, I'd like to allow this application to access this and this for me. You get redirected back to the code in the front channel. So this code now, the reason we need Pixie is because sometimes you can rob the code and replay it in a different session, but I'll come to that later. So the code goes back to the application. And what happens then is that not the front end, but the back end of this application then will send this code along with a secret and say, can I have access token, ID token, and a refresh token if you request the offline scope? Not all IDPs do this, but most of them do. That would be the specification. And the secure token will server say, yeah, the secret is correct, the code is correct. Yes, there's my tokens back. Now, there's another step after as well. In the OpenID Connect specification, you can request the user info endpoint, which is a common way of getting the profile data, and then you can remove all the claims from your ID token. You don't need to include anything in the ID token if you want, and you can put it in a next request, which will be just then the user info endpoint. And then when you get this data back, then you have all the information for your authorization. It's all in your backend, and then you can secure the tokens. And what you do then is, and as we do in the code, then you persist this in a cookie, and then you give the cookie back to the front end. So every request from the user, the browser agent, to the back end is all with a cookie, and that same domain, same site protected, and then you have your anti-forgery protection as well, and everything's safe. So this is the most secure of all the flows, and this is what I tend or try to use everywhere if possible now. So with Pixie, of course, the Pixie I'll come to later, but you should always use Pixie if possible as well, because to prevent session or man-in-the-middle attacks with the code.
Okay.
Okay, so the next flow I use a lot and is the OpenID Connect hybrid flow. So this is almost the same, and this is just as safe nearly as the OpenID Connect code flow. There's one major difference here. In step 3, when you get the code back, you also get an ID token back. And in the ID token, this really thing, you don't actually need the Pixie for this flow. You're already protected from this robbing of the code flow, because in the ID token is a thing called a C hash, and the C hash can be used to validate the code. So what happens is when I try to send in the application and a code that didn't come from the first request, someone else sent it and I robbed it off them, and I tried to send it my application to send the code again. The backend application, if it's done correctly, validates as the C hash and the code match. So you will not send the token request then. So you're also protected against this robbing of the code or session hijacking. So it works almost the same way then, except in the request tree, you get the ID token back as well. And it's not so bad getting the ID token back after the first step, because it's just user information. It's maybe I get some information P2 data over here, but I actually cannot get access to your access APIs or whatever. It's a little easier to set up, but yeah, I see it's just as secure and just as safe as the OpenID code flow with Pixie. You can also use Pixie with this as an extra layer, but it's not needed. And we don't actually need this because this covers the same use cases as the OpenID Connect code flow with Pixie. So maybe you can just say, I don't need the OpenID code flow, the hybrid flow. I only need the code flow. And with that, then you can reduce the amount of flows you have to learn off by heart. But if you are using this flow, there's only one you can use, actually, there's 3 of these flows, the code ID token flow. If you're using that one, there's no problem with it. I had one client that wouldn't let me use this because they read somewhere that's unsafe to use the implicit flow. And this is not the implicit flow, it's the code flow with the confidential client with code ID token. And then it says, yeah, but we only support the code flow with Pixie now. So people are starting to not accept this anymore, even though I don't see any security risk with it either. So it covers.
One quick question to make sure I'm following. The code, is that the, and apologies if it's a dumb question, is that the code like I would type in a 2-factor auth, or is that a transparent thing that's just flowed across? Or
No, that's part of the flow. That's something you don't touch ever. This is in the application. So this is what the OpenID Connect server produces in this as a result, and this can be used then in the second step to get your tokens back, which you need to use then. So it's part of the OpenID Connect specifications and how the flow works as well. So you as a user never touches this, never touch it. Okay, so and then you can nearly forget about this if you want. You have to use this a lot in Azure for some portals, but you don't need to know this either. The code flow, this one with Pixie would be enough to learn. Then the next flow is what we use for native or the untrusted applications. So the code flow with Pixie is what we use in a mobile application, a desktop application, a console application, anywhere where an application is running outside my trusted zone. So these type of applications cannot keep a secret. So anything I deploy anywhere else outside my trusted zone will use this type of flow. And the problem with this is you cannot keep a secret. And because you cannot keep a secret, then you have other problems. And the second problem was that people who are on mobile applications, you could actually rob the code. And if I was to send the code quicker back to the server as the application itself, I will get your access token and I can hijack your session. So I don't know who came up with it, or some people in the OAuth came up with the Pixie, the proof key of code exchange, which is a really great way of protecting it, because what happens is with this, you can prove that the application and that sent the first request is the same application that sends the second request. And what it does is it's really simple. You create a string which has to have a certain length, and then you create a hash of it, which is one-way encryption. And then you send the hash with the first request to the server. And then on the server, then with this, the server saves it. And then when I send the second request, I send the original value. And then the server hashes this using the same S265 usually. S256, and then with that, then if the two hashes match, then we know it's the request from the first that sends the second request is the same application, and that way it's not possible for me to rob the code and send it from a different application. So it's a really cool way. And then because it's so useful, people start saying, oh, we can use it for all applications. We can also use this for confidential clients. So they protect against two different things. And with a confidential client, you have a secret that validates the client, and then you have the Pixie that proves that the first and the second request was sent from the same application, which prevents loads of small or loads of attacks possibilities. So this is what you always use now with any single page application, with any mobile application, desktop application, console application, anything that you cannot trust.
Okay. And for all of these, there would be some sort of library or something, hopefully, that would implement.
Yeah.
Right? Okay.
In every single tech stack, you'll find a certified library that implements this in one way or the other. For mobile apps, you have AppBot, they're really good. You can implement it in Android, or you can implement it in iOS. There's really good libraries for that. And then for .NET Core, you have I don't know what the mobile app does, called the identity model. I think the OIDC, I think there's one of them. There's a few different ones you can implement as well. Or you could actually use in Blazor, you could just use the Microsoft Identity, for example, if you connect against Azure or Azure B2C. There's always an implementation library which does all of the heavy lifting for you. And then you just have to configure your browser, and then that's it, more or less, because the redirect URL for native apps is the hardest thing. If you're working on a Windows computer, you have to redirect somewhere on your Windows computer, which then will be connect back into your application to pass on the tokens. That's nearly the hardest bit, but single page applications or console applications is really easy to do now, I think.
Okay.
So another flow which is really important is the OAuth device flow. So again, I took this from the specification. So this is really useful for, just say you have for example, a PlayStation or Xbox where you don't have a good user input. So I don't have a full keyboard. I don't have access to a good way of doing multi-factor authentication. So if I have a 50-character password, it's really difficult to give that in my game console in to do a proper authentication with password. And then I'd also like to do a two-factor authentication always. So it gets really difficult to do that on a TV or on a Samsung device or whatever you're using. So with this flow, then it makes it really easy for machine or small devices to create a relative secure way of authenticating your users without having any problems. So what it does is actually when I start up my, for example, I want to log into a PlayStation app, I can click login on the TV, or if I have touch screen, I can click login on my computer or my machine. And then what happens then? It starts the login process, and then you get the STS server which supports it, or the IDP that supports it, sends you back then a code and a verification URL which you can then use to log in. So then I take my mobile phone, I can it could be displayed as a QR code. I can just give it into my computer, I can scan it, and then on my mobile phone, that I can enter my password manager, my 50-character code, and after that, then I could use my FIDO key to do two-factor authentication, and then I log in. And then on the phone, it would say, congratulations, you've successfully logged in or signed in. And then in the meantime, what's happening is the device itself is polling the authorization server. And then the next time it polls the server, it keeps asking, do I have a valid session yet? Do I have a valid session yet? And the next time then it goes, oh yes, now that you have a valid session for this code, and then it will send back the access token, ID token, refreshed up if you need it, back to the device then, and then you're authenticated. And this is really useful and a good way of authenticating if you have no good user input. But it has one big problem with it. You cannot protect against phishing with this because this is a cross-device authentication, which means that if you are using a phishing website and not the proper authentication server, you have a problem. So you should only use this if you have no other choice. If you're able to use different flows, you should always use different flows. I've seen this being used now in Windows, mobile or desktop applications because it's much easier to authenticate when you don't have to open up the browser and you don't have to do the redirect back to the local host or whatever special URL you're using. But you should never use this unless you have to use it, I say, because you cannot protect against phishing with this flow due to the cross-device authentication. And that's something that we don't have a solution for at the moment, unless you're using certificates.
And this, you talked through like the console device thing. That's where I remember using this last. It's just like on an Xbox, right?
Yeah, it's perfect because you don't have good inputs, and then you say, okay, for a console device, you can type a live with phishing. You can't have everything in.
Okay.
It's, I don't know. Actually, maybe we get a solution at some stage, but I don't know of any known solution for this at the moment. So the next flow I think is really important to know is the on behalf of flow. This is really interesting. So what I did is I went to the Microsoft Docs for this because they have a really good diagram showing how this works. So this use case is I have a UI application where I log in as a user. I use probably, so say this is ever in the application, then I use a code flow confidential client with Pixie, and then I get an access token, user token back. Okay, and then this API needs to get user data from a separate API, but this separate API is not publicly available to my U application. There's no direct access. And I also don't want to use the web API B or the second application direct in the UI application. So what I can do is then this thing called the on behalf of flow. So what happens is that the application sends the user access token to web API A, and it has a secret then. It says, can you give me a user access token which I can use for web API B? And this is the user access token I got for my client. And what happens then if it's all is okay in the client secret and everything is correct, you get the user access token back for web API B, and then they can request the data then from B, goes back to A, and then you give the data back to A. So it's a way of delegating a user authorization to a API which is not reachable from the UI. And this is really good because if I wasn't to do that, then I had to give an application scope or the full rights from B to A, and maybe the web app B does not trust web app A. I only want to do user authorization or user authentication, and I do not want to give the full rights to API A, because what happens is then the only difference then in every API call is the parameters, and I could change the parameters if I'm messing with API A. So it's a way of reducing the rights or the scopes you have to give from one API to the other API. So I always say try to use user access tokens if possible everywhere. And with the on behalf of flow, then it's really simple actually in Azure AD to implement this. It's not supported from Azure B2C. And then if you were to implement, for example, in Identity Server 4, I think I've seen a really great example from Kevin Dockix, I think it was. I seen it. I'm not sure if it was him. He produced showed how to implement this using Identity Server. So it's a standard and it's easy to implement, and it's really easy to use in Azure AD. And I think if you can use this, you should always use this when you have to use downstream APIs from an API. So it's or maybe you have a network firewall between API A and API B, or API B could be an internal application which is not reachable from the public application. There's many different use cases. So this is actually really something really good. I'll show how this works later as well in the code example. So the next flow is the resource owner credentials flow. So this is really simple. This is no user now. This is OAuth and not OpenID Connect because there's no user involved. So this is one of the most simple flows. A trusted client, that's a client that has to be able to keep a secret, wants to get an access token to access an API which I validate against my auth service. So it's really simple that the client then say, can I have with this secret and this client and this scope maybe, can I have an access token to access this resource server? And if you have the proper credentials, I give you the tokens back and they can access the resource server. The auth service cannot validate who sent it or where it came from. There's nothing over that. You no idea. All you know is if you send me this data and it's correct, there's your access token. So it's really simple, but it's really useful from app to app where you trust the application, where you have it can keep a secret, for example, and then you can use this flow. This is really useful if you have multi services maybe which need to in the back end communicate with a different API or whatever. There's different use cases where you use this quite a lot. But you should only use it in a trusted environment. Now there's different flavors of this. Sometimes you can people use certificates instead of secrets. But yeah, all of them are more or less the same. But the thing is, there's no user involved. It's an app to app, and this is something where yeah, you don't have many use cases, but it's really useful for when you want to have a trusted app to a trusted app where you give them the full rights to access the API. Then the client and the resource server are the same security context more or less. So the next flow is almost the same as that, and this is specific to Azure. In Azure, you have a thing called managed identities, and they're just a special type of service principal. And when a managed identity, it's the same thing. It covers the same use case as a resource owner credentials flow. You can use this from an app to app to allow access from one application to the other application. And what's nice about this is that Azure takes care of all the management and the handling of the secrets. So you just have to find that this client has access to this service and it does the rest for you. So you don't have to save and manage secrets anywhere within your application scope. It takes care of it. And there's two types of managed identities. SaaS keys we don't use anymore if possible, but there's a system assigned managed identity and a user assigned managed identity. So the difference is that a system assigned managed identity belongs to the application or resource that you use in Azure. For example, if I have a Azure App Service, and when I create that and I create a managed identity for that, it belongs to that. And when I delete the Azure App Service, the system assigned managed identity will also get deleted. Whereas a user assigned managed identity, I create it myself and I can use it in many different applications. So when I kill the applications or the services, this will continue on to live. So you have to actually be careful to also delete your user assigned managed identities when you're cleaning up your resources. So this is really useful if you have many services and you need to create RBAC access using a managed identity to access server 1, resource B, and whatever you need. So then you don't need to create multiple system assigned and use multiple RBAC definitions. You can just use one definition and then connect into many different applications. So if you're in Azure, I try to use managed identities anywhere where I have an app-to-app security. Now, if you're using a user access token or a user delegation, you should never use this because you don't want to give app-to-app security if possible. You only do that if it really is a back-end service where no user is involved.
Okay.
High speed, huh?
Yeah. Okay. So there's a lot of questions that have come in. Some are more in depth and I'm holding for later, but one I realize is probably worth covering is, can you explain what a token is in detail? Because that's
Okay, so
something that all of these are using, right?
yeah, so okay, there's three types of tokens. You have access tokens, and then you have reference tokens. You have ID tokens. So an access token is something I use against an API or backend, and you never open up a user access token in that UI application. You request an access token from a UI application or an app, and then you send this to the server. And there's two flavors of access tokens. One is a reference token, and the other is a self-contained JWT token. And the difference is that with a reference token, it's a reference of um, a a session or a token as well. And the secure data, the secure information never has to leave the trusted zone. So when I give a reference token back out to the application itself, this reference token then can be invalidated using a revocation endpoint. I'll explain that later as well. But you have two types of access token, and you only use against APIs or backends. Then you have the ID token, and that contains information about the application or the identity that logged into your IDP. So just say I did a login with my single page application for user X, you'll get an identity token back, and it will contain claims. It's always a JWT self-contained bearer token. And in this token, you have the information then that you need to validate that the signature is correct, that also what claims, what user, what identity is in it. And then there's 5 or 6 standard claims defined in the OpenID specification, which you validate always on your UI application. Now, in the definition of the claims, it's really important you validate these claims, and also what you get back and what's inside the ID token is not always the same, but there is a subset which is always there. Um, Part of your identity could also be returned in the user profile, not just in the ID token, but the ID token is only for the UI application. You can never send the ID token back to a backend service. It's only used for the UI application. If it's a server-rendered application, you can use for authorization. If it's a single-page application on desktop, then you use it for usability to show and hide displays and so on. And the third type of token is a refresh token. And this is a token that you can use to update your session, because the first time you log in, you have to give your consent, you give in your username, you do your two-factor authentication. And then you don't want to do that every hour if you have an hour time span of your tokens. So the next time you need to update your session, you don't want to re-log in. You can use a refresh token to get the next session. And then
Uh,
if you use the refresh token, then it will give you back again another user access, an access token, ID token, a refresh token again, and they can use them to get the next session an hour later. So a refresh token is a way of continuing your session without having to log in again.
okay.
Does that help?
Yeah.
So there's 3 types of tokens you need to know, and then there's 2 flavors of access tokens. And then of course you can
Yeah.
encrypt all of them as well if you want.
Yeah. Okay.
Any other questions before we go on?
Gosh, let me think. Let me see if there's some of these I think that you'll probably continue to cover
Mhm.
as we go on. So, yeah, let's keep. There's one other one. Uh, Signalr or something like that in general. How
Mhm.
would you? Where does that fit in?
Okay, so Signalr is built upon WebSockets. It falls back to other mechanisms, but Signalr has a big problem that there's 2 ways of authenticating Signalr. You can use a cookie or you can use a access token to access the backend. And the problem with access token is you cannot add a header into a WebSocket, so you have to add it into URL. So every time I authenticate with Signalr, I'm actually sending the access token to URL. It is encrypted, it's in the browser, but it will get saved to session logs, or if you have administration logs, you'd probably find the user access token in your Signalr logs somewhere. So you have to be
Mhm.
careful that it doesn't get logged. So the problem with WebSockets is that you cannot send the access token in the header. So to authenticate, if you're doing Signalr, keep the access tokens a short life cycle if you use single page application. Whereas you're using cookies, for example, using backend for front and using Signalr, then to open up the session that you can use the cookie and it will get sent and you can use that to authenticate your Signalr session. And once the WebSocket session gets started, then you don't use it anymore. It's just to initiate the connection. So there's 2 ways that you can either use cookies or you can use access tokens. And what some people do is actually to use a separate access token or a separate key generated from your access token, so you don't be sending the access token in the URL of your request for connection. But it's encrypted. The parameters from the URL is encrypted, so it's the only danger is really of both sides where it gets in the logs or the administration logs and so on. So, but it is in the URL, and you don't want to put access tokens in the URL if possible.
Okay. Well, one other thing that's come up, so this is amazing as a deep dive, and we're like covering a lot of different flows, which is great. Some people are saying this is kind of crazy over my head stuff. And one person said, like using recommended libraries, as long as they're following these specifications, they're gonna like. I think it's important to understand the flows that you're talking about to implement them, to pick the right flow, right? To pick a library that implements the right flow. But how I guess what would you say to people that are like, okay, how do I turn this into writing an application?
Okay, so I'll show 2 examples. If you're using Azure B2C, they have really great documentation on the GitHub Microsoft Identity Web, which shows you which flow you should use where. And then if you're using OpenID Connect, the actual implementation of that is really simple. I can show you that after as well. It's maybe 10 lines of code where you show you which code you use for which application. And I nearly always use client credentials with confidential client, or OpenID Connect code flow with a confidential client with a secret and the Pixie. And that's more or less all you need to know for the moment. And then the other flows, for example, in Azure, you don't even notice sometimes you're using the on behalf of flow. Azure shows you that and does that all in the background, the client from Azure. And then when to use the open resource owner credentials flow, that's an app to app. There's no user. There's not that many rules you need to know. And then when you're using the clients, once you know that, okay, this is a server-ended application, I want to validate, I need a secret, I want to validate the UI application as well as the identity. And then you just search for the library which implements this flow. So it's actually only 2. You don't need the library for OpenID Connect because that's all out of the box where ASP.NET Core. And then if you're using Azure B2C, then you need to have the Microsoft Identity Web Client now. And there's little few differences in Azure because that's always a bit special, but I'll come to that later. And then on the OpenID Connect world from ASP.NET Core, every single IDP that you connect against, if you're authenticating to Auth0 or you're connected against Keycloak or you're connected against Identity 04, they all have the little differences. So you have some small little parameter differences in the configuration. So you just need to find out which configuration you need to use for which IDP. But it's actually small differences, and then there's little extra things you maybe need to change. For example, you want to add extra claims in after you come back, or you want to use the user in for endpoint. These are little events that you can connect into in your program file. Now, I used to always say startup file, but now we say program file because we don't have a startup. And it's actually not that much code, and there is really good examples out there. So if you know I'm doing a server-rendered application, then I want to validate the application, plus I want to use Pixie and CodeFlow, you're already making a great choice. And then you're doing a TV application or you're doing a machine input, then you know you have a bad input, then you can use device code flow. So I mean, there's not actually that many choices anymore. So it's actually starting to get simple again. Now, if you're doing high security or you need to do something really secure, for example, then you have to start in extra specifications. You want to add in maybe certificate authentication as well on the bottom. Then you need to know more what you're doing, and maybe you should ask someone or get advice. There's an awful lot of people that give you good advice out there. But most of your standard applications don't need that. So I mean, it's actually not that complicated, and the implementation that ASP.NET Core delivers out of the box without any extra libraries is really great. Now, if you're doing introspection, which I recommend a lot as well if possible, then there's good libraries for that as well, which is not it's not so easy to implement and the default implementation by ASP.NET Core. But there is good libraries in .NET out there which you can just use. So you can ping me and I'll send them to you after if you want to. So there's not actually that much to know. I think if you know what flow should be used where, and then when you're searching for your library which you want to use and you're using this IDP, you should find the right solution which is best for you then.
And I think generally what you talk through, each of these flows has a specific use case, but in general, I think you started with like kind of top to bottom, the orders that you'd normally want to pick. If possible, pick the top one, right?
Now, I always should use the top one. And the only time I don't use the top one if I'm doing a non-secure, non-trust application, for example, a mobile application or a desktop application, then I use the third one.
Okay.
That's nearly always it. And then, of course, Azure, there's some specifics you need to know, but under the hood, they're using these two as well, more or less. They use the hybrid flow as well, but you don't need to know that because they actually hide it with their implementation. They're trying to make it more simple, but you still need to understand what to do. And I think if things go wrong, you need to add in a separate. For example, if you're doing a UI application and an app in the same deployment, things get a bit more complicated, and then you really do need to understand what you're doing.
Okay. All right, cool. So
Okay.
I think we've covered through the flows. We do have some more questions, but I would say let's continue on because the next thing I think you have on your list is spas. Is that correct, or did we cover?
Yeah. So single page applications now, how do you secure that nowadays? So I made a little chart which I showed to people. It makes it easy to understand. There's 3 different ways I think still which are valid. The third one is more or less you don't use anymore nearly. But there's 2 different ways or 3 different ways of securing a single page application. So a single page application is something that you cannot trust. And it's deployed on some domain, and usually you have to access an API which is deployed on a separate domain. And what I say is the best way to secure a single page application, I always say this, is not to implement a single page application, but to implement a server rendered application and deploy the single page application as part of your backend application. So it's the same domain deployment. Maybe you have Angular in one part and the backend is an API from .NET Core, and you secure them as one. And then between the view of your single page application, which is the JavaScript application, is a cookie, and the cookie gets sent back and forth. And that's also what people call the backend for front end. But you could also just say it's a server render application with 2 different tech stacks. So that's the way I recommend. It's the safest way, and the reason that is more safe than using CodeFlow or Pixie is without a trusted client is that you don't have to save the sensitive data in the session storage or in the local storage or in a session which is accessible from JavaScript. Sometimes they hide this now in a service worker, but you can still access the data from a JavaScript part of the application. So what happens if I was to find a XSS problem in your application, the first thing I try to do usually is trying to get your access token from you. Because once I have your access token, I can access your sensitive data in the back end. So that's what I'm always trying to rob. And with a cookie, it's much harder to rob the cookie as it is to rob a access token which is hosted somewhere or saved somewhere in between the requests in a local storage, session storage, or whatever. And that's the reason. It's the main difference. It's not actually what's sent back and forth or the flows. I don't see the security flows aren't any different or not any less secure, except that all my security implementation is also in the back end of the trusted rendered application. But there's another little thing as well. You can also log out properly because it's impossible to log out from a front channel and a single page application. Whereas I'm having a server rendered application, it's always running in the back end. And I can also send a logout request to say the next time this user comes to your application, I want to force a logout there, please. And you cannot do that in a single page application. So it's much easier to do implement complex logout with multi-application systems with a server end application. It's impossible actually with a single page application. And then
I think you answered a question here, but I just want to make sure. Authentication scheme, what's better for a single page application, cookie or JOT? And I think you said a cookie because
it depends. You see, if you're using an API from a separate domain, then you have to use a JOT because you have to go cross domain. Unless, of course, you're going to route all your application requests through your backend, and then you go from your backend with a YARP or reverse proxy to a different domain, or you can do a HTTP client as well. But then you're going to lose lots in performance because for every single API call, you have 2 API calls or a redirect, whatever depends how you implement, but you're still going to your backend and then to the other domain. Now, if you have high performance requirements and you need to access these different APIs which are deployed in different domains really fast, and your security requirements aren't that high, maybe, then you're actually better doing an OpenID Connect code flow with Pixie and not using cookies because you have more performance, and then you don't have any session as well. You're just using access tokens. So there is advantages to not using cookies. So if you're in a where you have thousands and thousands of users and you need really high performance, you're probably better off using OpenID code flow with Pixie, but then you have a bit less security because you need to manage the tokens in your session or your local storage. Now, Angular and React are getting really good as well at protecting against SSS. They're improving the whole time, and it's getting harder and harder carry out these attacks if the UI application is implemented correctly. But that doesn't always have to be the case. So it's getting harder and harder, but it will always be possible because you always have this sensitive data which is reachable through JavaScript. So that's the problem. And then for me, the OpenID Connect implicit flow is not really any much less safe than the code flow with Pixie. The only problem with this is that it's a single step authorization authentication. And when you get the token back on the authorization request, it's returned in the hash of the request, and that gets saved a lot of times in the browser history, or it gets saved in logs again. And it's just a small chance that could leak, and you don't need to use that anymore if you can use the code flow with Pixie anyway. So sometimes they don't support the code flow with Pixie, then you have to use the implicit flow, but it's not massively less safe than the code flow with Pixie because the main problem is not this history. You can delete the history and everything, but you don't need to use it anymore. The main problem is where you store the sensitive data in between the requests. And that's what we avoid. And if you use cookies, we're back in. Now, of course, maybe in 6 months, then we discover that cookies are no longer safe again because this and that and that. And then we go back to using access tokens again. It changes regular. So at the moment, cookies seem the better way to go. And then we have the CORS pre-flight, which protects against anti-forgery as well. So things are getting better, and the browsers are moving in this direction because they're blocking iframes, which we use to refresh the sessions as well. So if you're using the middle flow now, you have to use refresh tokens to refresh, and refresh tokens were never actually designed for in the browser with single page applications. So there is problems with that as well.
So it seems like the simplest case is the green path here. If I can deploy the front end and the back end on the same server, on the same domain, that seems simplest, right?
It seems, but it's really dependent on your tech stack and what your thing. I'm a great believer in KISS, which is keep it simple and stupid, or to keep it stupid and simple, whatever I don't know which way it actually is proper. But if you're implementing a really complex security architecture because your tech stack doesn't support it, it's probably going to be worse off than just using what they recommend, which is maybe the OpenID code flow with Pixie. Because if you're implementing loads and loads of codes to do best practice, and then they do an update 3 months later or change stuff, it's going to be really hard for you to maintain this application and update it as well. So the more code that you write and the more you move away from what the tech stack recommends, the harder it is. And then where to find the balance, because if you're implementing too much code, you'll probably be making mistakes as well. So some tech stacks don't support cookies and backend for front end so well, and sometimes maybe it's not doesn't make sense to move away from this in the moment. It depends. We're not all implementing super high security, super secure applications. We just need a solid security, and then we need to protect against most of the basic SSS attacks, and then maybe we're good with that. Maybe we don't need to go the full security path. So you have to keep it simple. If you're doing complex solutions, it's also bad.
What do you so if I do file new project Angular or React, so there's those include an ASP.NET Core integration with React or Angular. Is that something that's easy to secure using that green path, or?
Okay, so it's not quite actually that simple. You'd have to do some stuff yourself. But Identity Server, they've implemented a library which does backend for front end. And I haven't tried it myself, but it looks like it would be really easy to implement this green path for Angular or React using their library.
Okay.
But I've never actually tried it, so you can ask them yourself directly. I'm pretty sure they give good feedback. It looks simple and it looks good.
Okay. All right. Let me see. I'm trying to cover through what I'm already picking up. There's a ton of great information. I'm expecting we've got like, say, 10 more minutes. And then I think what we should do is just schedule to bring you back, and we'll just keep going through this if you don't mind.
Yeah, that's cool. It's great.
Okay.
So I wanted to show some code examples then. If we're
Yeah.
going to finish on 10 minutes, I'll skip the API bits and I'll skip the other bits. One of the I just want to show how simple it is in implementing an OpenID Connect client, for example. So I have this is an application I use, and I have in the application to test it. It's just probably too small. I'll just explain it. So I have a OpenID Dict identity server, and it implements my clients. And this is usually something I wouldn't implement myself, or if I was implementing myself, then I'd use something like this, or identity server. And then on the clients, then I authenticate against this. Now, this could be any OpenID compatible client. It doesn't have to be OpenID Dict. It could be any other server, Keycloak, Auth0, Okta. They all support OpenID Connect. So, for example, I implement a Blazor backend for front-end architecture here, and all I need to do then is secure my whole application, my Blazor, and that's all in my trusted backend. So in the server part of the Blazor application, in the program file, I have it open actually. The only thing I need to do here is secure, implement the right OpenID Connect flow. So if you see this is all the code you need to implement an authentication using no libraries, no extras. It's just the basic, what you get out of the box in ASP.NET Core. So what you do is that you have a cookie to store the session, and then you have your OpenID Connect to do the challenge. So when I want to log in, I have to say against which authority, which client ID, and which secret, because I want to validate the client as well. And then the scheme, I'm using cookies to store the information after I sign in, and then I'm using a code flow. So I'm using code flow with Pixie. I don't have Pixie configured here because that's default at the moment. And then I want to save my tokens, and I'm using actually user info endpoint here as well. You don't have to use that. You can use it. It's up to yourself. And this is all the code you need to implement this with no extra libraries, no extra features. And my complete Blazor hosted in a WASM application is secured with this alone. So it's really
Wow.
simple.
Okay.
And that's why it can be simple. And there's no extra libraries, no features. No, I have for the session headers the Andrew Locks library always, but I'm not using anything special. And then I'm using OpenID to server. So what I'm saying is you never actually have to implement accounting. You don't actually nearly ever need Microsoft ASP.NET Core identity. You only need that if you need to implement the accounting yourself. Now, if you want to do quick and dirty, you can implement against Azure AD or Auth0. There's lots of servers hosted identity providers, and you can just use one of them to connect into, and then that's all the code you need. So there's different little bits of difference as well, of course. As soon as you start doing extras, you want to add in extra claims, you want to do an extra request, you can hook into events from the OpenID Connect server, but you usually don't need to use them. So
Okay. So
Blaze,
this OpenID Connect, this is authenticating against which you could set that up to whatever OpenID service for authentication.
Anything that's conformed to OpenID Connect.
Okay.
And this is the server end application. So it's a OpenID Connect code flow with Pixie confidential client.
So as a, like I'm implementing an application with this, what's a list of some of the top like OpenID Connect services I could use to authenticate against?
Okay, so if you implement it yourself, then go for OpenID Dict or Identity Server or Keycloak. There are three really good ones. Keycloak is actually a Java implementation, but it's really implementing an awful lot of best practice, best standards. You get an awful lot of the new security standards really fast here as well. So it's one I consider now when I'm using as well. So they're the three I'd use if I'm doing an implementation myself. But if I'm serving against a service, then I use Azure AD, Azure B2C, Auth0, or sometimes I consider using Octet as well, but I've never actually used that productively anywhere yet. Auth0 I've used a few times, which is very good. And the Azure it's really good as well, but it has little things that don't work really good as well, but it has other advantages as well. So they're the service I'd use for OpenID Connect. I would not use that direct against Azure. I'd use the Microsoft Identity Web against Azure because they do a few little bits of extras and they do it slightly different.
Okay.
So yeah, there's not one of me. That's more or less all the ones I use, and they all have their advantages and disadvantages. You can't say one is better than the other. It'd be cool if they all came together and start supporting each other because all of them are great actually, and it makes it hard to choose when you ask one of them which one would you recommend, and they always recommend their own solution, which is logical. It's normal, but it'd be cool if we could have people recommending all of them maybe, and then you get to know, okay, this is my type of architecture. It'd be better to use this type of IDP, or this one suits me better in this use case because I need to do this and this and this. They all have their advantages.
Yeah.
As every software, and then another thing I want to show as well, what's really good is that in the Blazor BBF now, you'll see that in my client application, I have absolutely no security here. So this is just more or less a view from my server end application. I have absolutely no security implemented in this. You don't need the MSAL, or you don't need an OpenID Connect SPA client here. I have no need for any security libraries here. It's just a view of my backend. So it's really handy. And then I'm using cookies to access my API. So if you look at the how I protect the APIs here, that's the wrong one. Go here. I'm using cookies to protect it. So I have to find the scheme cookies authentication, and then I have to present the right cookie, which is same site protected. And then in the front end application, then or the front end view, I should call it. I have an authorization handler that always adds the anti-forgery cookie protection. Because I'm using cookies, then I have to add in a few extra bits and pieces. Now, if I'm doing a PWA application, then I'd have to use the CORS pre-flight check. But then I have a few other little problems as well with this as well. But you have solutions for everything. And then the whole application will only work together as one deployment. So I have one application, and it's really easy to implement, I think. So what I did is to make this easier for people to use. Do I have it open here? Where are we? Browser. So I created a template actually for implement Blazor backend for front end somewhere. There. So this template for me, I have 3 templates now, which is a really easy, quick way of getting support for implementing Blazor, a WASM host and Aspen in the core application. And what you can do with this, then you can just implement your template. So you have to just install it with the .NET tools. We all know the .NET tools. Cool template for .NET, I think. So once it's implemented, the second step, then all you have to do is create a new application. Really easy to set up your own templates as well. Now I have it ready to go. All I have to do is now configure the security for this application. And configuring the security now for this, all I have to do is in the server then is add the app settings for my OpenID Connect settings then. And now I can connect against any OpenID Connect server. I have the best practice for security. I just need to set the 3 settings here. This will be in my user secrets, and I have the same setup for a Blazor Azure AD application and an Azure B2C application, because both of them are slightly different. I always use GraphAPI with Azure B2C as well, but you don't have access to an awful lot of things in GraphAPI because you don't have the on behalf of flow. So you have to use an app scope and you have to use it slightly different. So I created 2 separate templates for Azure AD and Azure B2C. And the templates then has no dependencies to anything. That's what I think. It's all just pure .NET Core apart from this library, which you don't have to use, but I recommend it. And this is where I do the protection for the security headers. So this library here is what I use to protect my session. And it's actually really simple to use then. I just add this in, the definitions. With this, then I can define a policy that blocks everything that I need to block. And then the CSP is the hardest thing to define. This changes a few things. There's a few specialties with Blazor, but it makes it really easy to find this. And then you know you have a correct policy, and it's easy. You can validate against the security headers, and you can validate against Google. The hardest thing is to find the content security policy, but then you get everything more or less out of the box without having to implement it. Now you could remove this, you don't need this, and then we just have pure .NET. We don't have any external dependencies anywhere in the application then. And that's why for getting started for Blazor, WASM hosted, it's really easy to BBF.
Okay.
Be best friends forever.
And this is included in your template that you were showing.
Yeah, this is all comes out of the box out of the template. So it's you can use it if you find problems with it or something wrong with it, just update it. It's just no guarantee it's MIT, but I use this for getting started because I prefer this security pattern to do 2 separate security architectures, one for the WASM and then one for the backend, and I have 2 completely separate security solutions, and then I connect them together. That's what we get out of the box of the templates at the moment from ASP.NET Core, which they have their advantages as well, but this is what I prefer. Now, if you're doing Angular or React, the identity server have a good BFF. You could also use that. It's a very good solution. Or if you're secure anyway against identity server as your backend IDP, you could probably consider using their BFF library. They have a slightly different solution. A lot of the stuff is very similar, but I haven't really studied it, but I'm assuming it works in the same way.
Okay.
So that's one of the things. And then, for example, APIs, we're running out of time. I'll actually show the Azure AD stuff because that's important. An awful lot of people do Azure. When I'm securing against Azure, for example, the UI application is really simple as well. They make it even more simple to use, but you need to maybe understand more what you're doing.
Mm-hmm.
Everything's hidden, but there's excellent support, and this library here is called the Microsoft Identity Web. It's what you always use in any web application. So you always use this library if you're securing against Azure AD or Azure AD B2C. And if you're doing a UI application, then you have to add in the UI library dependencies as well. And then you can secure pretty much really simple for most of the basic use cases. So if you're looking for information to how to set this up and run it, and you want to secure your client against Azure, the GitHub repo, Microsoft Identity Web, has brilliant documentation, some brilliant samples, and it makes it really easy to get set up. So for this example, it's a little bit more complicated than usual. I have a UI application, and then I have a downstream API which gets scopes for the access token. So what I'm doing here is that's all I need to set up here. Plus I need the configuration for Azure AD, which would be this is my configuration here. And then my client secret you don't see here, but the client secret is in my user secrets or my key vault then. And then getting this set up, you can let them generate everything for you, or you can generate it yourself. It works really well, I think so. And then what I have is a downstream API here. Yeah, maybe we're running out of time, so people could ask me questions later. I can go on to it, whatever. But that's pretty much what I use nearly for all my applications. And then when things go left or right, or maybe I have to do special deployments or whatever, then you need separate things.
Okay.
So
let me see if I can cover what I learned and see if I got the right things.
Cool.
So first of all, you shared this amazing repo. I just shared it in the chat again recently. And this has all your resources, including your code and everything that you've shared here.
Yeah.
So you talked about the high level things that you need to understand, the different security topics, and then you talked through the authentication flows. And then towards the end, you showed implementations. And I think for people that were like, wow, this is a lot of information, seeing the actual code that you showed, which is all linked off of here, actually simple. It's not super hard once you've picked the right flow. Does that sound about right? Okay.
Yeah, that's it. So I think it's actually once you're using the correct flows, you know what you're doing a little bit, you understand the basic concepts. The coding and that is not actually that much. And then once you have your authentication correctly, then you have to do your session protection. You can use a lib. There's two libs. There's another one as well I haven't used in a while, but you can implement this yourself again, or you can use that from Andrew Locke's session and security editors. That's the second problem solved. And then the third problem is then you have to implement authorization. That gets complicated and that's business specific. That's always different for every single application. And then, of course, then the logout was always something or single sign-on. So another thing is you should never need to implement your own user account. And that's another message. You should never need to implement ASP.NET on a core identity in nearly any applications that you implement. You only need to do this if you want and have to do your own user account and management. So for example, if you're using a legacy account and you need to connect it to a modern application, you could link it over identity, or if you're implementing your own identity server, for example, identity server as your IDP or OpenID Dict, then you have to have some type of identity management, then you need it. But I nearly never need that. You can nearly always just need to implement a client and then consume an account from some identity provider service.
Okay, that makes sense.
You can keep it simple. That's why templates is maybe we don't need all the templates. Maybe we just need 3 or 4 basic OpenID Connect and maybe 1 or 2 Azure templates, how to implement the client.
Okay. And I liked how, as an example, you showed one of the cases where you said it was OpenID Dict and the code flow was just one of the enumerated settings on there, right? So you can pick. So exactly. So
this one I showed somewhere.
Yep. Yep.
Where's it?
Program. But the general idea of exactly there, switching between the different flows and things, those are just settings on the response type there. Yeah.
So there's probably got a list. I should have there. There you have them all. So actually, the hybrid flow, you only ever use the code ID token flow. You never use the other two. They're no longer recommended. But you don't need that either. Just use the code flow and you're safe.
Okay, great.
And Pixie is default, so you don't need to configure it.
Okay. All right, this was awesome. Thank you. I learned a ton. We got a lot of great questions, and I think it would be good to. I'll connect with you, and we'll set something up in another month or so, and we could keep digging into this if you don't mind.
Yeah, it's cool. I love talking about it. It's great. There's so many new cool things coming out. So there's always anyone wants to get into security as well. Just ping me, and I could start helping you getting moving that direction as well. It's really interesting. It's really cool to learn.
Cool. Awesome. Okay. Well, your connection information is in the in the description on YouTube. The shows, as always, is recorded. And then question, like for instance, somebody asking about like two-factor, and somebody else asking about Maui, and there's all kinds of other stuff. So I think we can go deeper on a lot of this other stuff.
Cool.
If we check back in a month or so. Awesome. Thank you so much for your time, Damien. This was amazing.
Thanks for having me. It's a pleasure. Delighted to be on the show.
Thanks, folks.
Hopefully everyone else watching was great.